Okay, we ready? We're still working with matrices. Today we are talking about determinants. It's going to seem like a random thing that we are doing with them, but there is a purpose. Okay, we use determinants for other things with matrices. So right now we're doing this because I said so, and then I will show you why we need them. Okay, basically you got to learn how to do it before you can learn why you care about them. So, all right. So every square matrix, so we're only dealing with square matrices right now, has a real number called its determinant. Okay. So to show that you have a determinant of matrix A, you can write it as DET, and then the A in parentheses, and it's a capital A, or what looks like the absolute value of A, but it's not the absolute value. It means determinant because the A is not a number, it's a matrix. Okay, we're okay with that? So we're going to start with a 2 by 2. That's what makes it square, right? And so the determinant of a 2 by 2 matrix is called the second order determinant. All right, so here is the rule that we use. This is what I think you were asking about yesterday. You multiply diagonally right here. So we would multiply A times D. And then we subtract this diagonal, which is C times B. And that is equal to the determinant of A. Do you need batteries? Okay. All right, so I want you to notice what I did. When I did this, the way we do the diagonals, we did down and then up. So your actual rule here is down minus up for the diagonals. Okay, down minus up. So if I look at number 1 here, I'm going to make a down diagonal. It's going to give me -4 times -10 minus the up diagonal, which is 5 times 3. So that's going to give me a +40 minus 15, and that's 25. So your determinant is 25. Easy enough? So here, down, -6 times -2 is a +12, minus 11 times -3, that's -33. So that becomes plus a positive, and you get 45. Okay, you do the next two if you haven't done so already. I'm going to put on here what you should get. Make sure this is what you get. Don't just write it down. No. Okay, thank you. But wait till we're done because we'll have time at the end. Okay. All right, I see some erasing. Let me make sure that we're, if I do this, that gives me a -45 minus, this is a +35. That's where I get my -80 from right there. And then this is -16 minus 24. Okay. We good on those? Okay, so the 3 by 3 gets a little more intricate. Let's look at these steps. So a determinant for a 3 by 3 matrix is called a third order determinant. Here are the steps. We first have to rewrite the first two columns to the right of the matrix, and then we do the diagonals, but you'll have more than one diagonal, so you have to do the sum of the products of each downward diagonal. Sum of the products, that means you multiply and then you add. Okay, so we are going to, I'm going to write out a whole bunch of stuff here so I don't lose anybody on this, because it sounds weird, it looks weird, not that bad in the end. Sum of the products of the upward diagonals, and then you subtract them. So it is still down minus up. Down minus up is what we're looking for here. Okay. So the first thing it said to do was to rewrite the first two columns to the right of it. So I'm just rewriting 3, -5, 1, -7, 4, 5. Okay. And then we're going to start by looking at our downward diagonals. Okay, this is the first one right there. There's 3 in that diagonal. So I'm going to multiply 3 times 4 times a -1. That gives me -12. Okay. Then I do the next one. That is -7 times -5 times 1. It's a positive 35. And then here's my third diagonal. That's 2 times -5 times 5. So that's -50. Okay. So I did the product of each downward diagonal. Then I need the sum of those products. So I'm going to take my 3 answers and add them up. So that's going to give me, is it -27? Somebody with the calculator check me. Okay, -27. Okay. Product of the diagonal, of each diagonal, and then you add up your results. Then we do the upward diagonal, starting in the bottom corner here. This is my first upward diagonal. So this is up. And that's going to be 1 times 4 times 2. That's 8. Next diagonal, 5 times -5 times 3. -75. Then I got this one is a -1 times 1. Nope, I'm sorry. Times -5 times -7. So that is a -35. So I think that's a -102. Somebody check me on that. Any questions about where any of these numbers are coming from? Okay, but I'm not done, bless you, because I have to do down minus up. So that's -27 minus a -102. That becomes plus a positive. So is that 75? No, it is not. What is it? 75? Okay, I totally have 82 written down over here. This is why I'm questioning myself. I was like, I don't know what's happening. Or 75 makes sense. Yeah, okay. Okay. Any questions at all on that process? Does it seem a little weird? It's a little weird maybe, but it's not difficult. But depending on how neatly you write these 2 columns might determine how well you can actually see what the heck is going on here. All right, so let's do one more together, and then I'm going to have you do one. So we'll do 6, -1, -3, -3, 4, -6. Okay. So we're going to do down and up. Multiply these three. So that is 6 times 4 times a negative 4, which I know will be a negative number. And that will be 24 times 4, negative 96. Then multiply these three. Negative 3 times 2 times negative 3. 18. And then these three. 6 times negative 1 times negative 6. Positive 36. You go ahead, work on the upward without me saying it. You can follow along if you need to. If not, try to do this on your own. And if you don't write all of this stuff out every single time, it's not the end of the world. Just make sure that you are actually keeping up with where your diagonals are, because it's easy to get off on those numbers for sure. Okay. Any questions on where any of the numbers are coming from? We're all good on this, right? Okay, because I think this is, did an eval come straight from Algebra 2? You came straight from Algebra 2, okay. So then that means you and William are the two in here that haven't seen it before. Okay. All right, so if you got that one, if you don't have any questions about where anything came from, you do number 7 on your own. Do we not agree on something? No, I thought you were confused about a number this way. Okay. Okay, how are we feeling about this? We good so far? Are y'all good? You good? Okay. All right. So here's one application of a determinant. So if I have a triangle in the coordinate plane, so let's just say I have these three random points, right? And I connect them. If all I have are their coordinates, then if I want to find the area of the triangle, the area formula we all know and love is 1/2 base times height, right? Which I could totally do. The problem is that if I use this as really either any of the ways I do the height, although it would be nice if I actually hit a point. If I do this, like I would have to figure out that length. So I'd have to figure out all kinds of things about the triangle that I may not remember how to figure out. I could find the side lengths, but that doesn't help me with this equation. But here's one way to do this. All right, now remember our brackets here don't look like what we always see them. These are actual brackets. One way to show a determinant is to do something that looks like the absolute value sign. It's either that or this. So when we already have that, this actually is the absolute value sign. Okay, because notice some of our determinants were negative. So if we get a negative determinant, we have to take the absolute value of it because we're not going to have a negative area. All right. So instead of 1/2 base times height, it's 1/2 the absolute value of the determinant. And our three ordered pairs that we have go into the determinant just like this. So we're going to write down our first row. This is x, y, and then a 1. So -5, -2, and then a 1. Then 3, 9, and 1. And then 7, -4, and 1. There is my matrix. Okay, just plopping the points in there, and then we put a 1. Then we're going to find the determinant just like we have been. Oh, I'm going to rewrite the first two rows. So -5, I'm sorry, first two columns. And then let's find the determinant. So this is my down. It's going to be these three. So -5 times 9 times 1, that's a -45. The ones make it nice, right? Then I'm multiplying this. That'll give me a -14. Then I'm multiplying this, which gives me a -12. So overall, -71 with a question mark on that. Somebody check me. Is it -71? Okay, good. All right, so then, excuse me, then we're going to go up. So 7 times 9 is, it is 63, and that's positive. And then this will give me a positive 20. And this gives me a negative 6. So positive 77, I believe. So then when I go to find the determinant is down minus up. So that's negative 71 minus 77. It's me a negative 148. But then my area formula that we have up here, right here, area is equal to 1/2 the absolute value of the determinant. So absolute value of 148, I'm sorry, negative 148 is 148. So my area is 74. What questions do you have? Anything? Y'all can handle the determinants? Yeah. Beautiful.